AB Cactus BC, Unit 6, Day 2. Notes, lesson, warm-up. So go ahead and try the lesson. I also want you to try and solve the differential equation and see if it kind of matches what you think the graph would be, maybe. So pause the video, try the warm-up. Okay, assuming you've tried it, I would look for where the slopes are 0, which is going to be when x equals 1 and y equals 0. So x equals 1 is a vertical line, and there should be 12 points and we're done. And y equals 0 is this horizontal line. So we just got half the points figured out just with that. It's never undefined. Plug some points in here. If we plug 0, 1, 0 for x, 1 for y, it's going to be -1. Plug 2, 1 in, you get +2. So maybe there's like symmetry here. 2, 2 would be 4, slope of 4. 0, 2 would be -4. 3, 1 is going to be a slope of 2. And 3, 2 is going to be a slope of 8. So there's your quick slope field. Now solving a differential equation, we want to separate the variables. Y squared over the y's, leave everything else on the right side. Dx, you can integrate both sides. This is the same thing as y to the -2. Right, so it's going to be y to the -1 over -1 equals x squared over 2 minus x plus c. I think I would rewrite this without a negative exponent. Now I can flip both sides of an equation, but it's got to all be like one fraction here. So you want to probably give these guys least common denominator. And think of it as x squared minus 2x plus really just c. 2c is the same thing over 2. So then we could flip both sides and multiply the other side by negative. And that is your general solution. We can't really do domain unless we have a specific initial value. So there you go. All right. Just more problems with slope fields, kind of thinking about how we can, do these without, the most efficient way possible. Use slope analysis to match each of the following differential equations with one slope fields, A through D. Do not use a graphing calculator. So I would first look for 0 slopes. I would do the things I would, a lot of times do if I was going to sketch, but so y equals x. So we're looking for one that has zeros along the y equals x line, which kind of looks like this one right here, right? So is there another one that has that happening too? I don't think so. So I think that alone, I'd probably confidently pick B for this. I'll talk about some other things we could do. This one be x equals 0. This would be when y equals 0 and x equals 0. So it should have 0 slopes on the x-axis and the y-axis. X equals 0 is the y-axis. So 0's on both axes. So this has zeros on the y-axis, but not the x. This has zeros on the x-axis, but not the y. This one has zeros on the x and the y. So as far as elimination, I'm thinking this one has to be D, right? This one could say, well, 0 slopes. It's going to be when x equals 0, which is the y-axis. And then undefined is going to be y equals 0, the x-axis. So we're looking for one that has zeros along the y-axis. It's A or D. But then infinite vertical slopes along the x-axis, which I believe that one looks like that. So I'm thinking A. This one equals 0, be y equals 0, which is the x-axis. And then equals undefined is going to be when x equals 0, which is the y-axis. So we want one with 0 slopes along the x and vertical slopes along the y. So I think that's going to be C. So just with that little bit, now some things we could do to take it a little further, just in case, is you can start looking at when the slopes are positive and negative. I look for 0 undefined, and then if I need to, I start looking for positive and negative. So I say, well, when is this positive? Well, that's going to be when, if you were solved for y, y is less than x. So that'd be a line right here, y equals x, and everything below it would have positive slopes, which that one does. And then negative would be when y is greater than x, which is everything above y equals x. Yeah, all those are negative slopes. That's kind of interesting. This one right here, positive, would be when x and y have the same sign, right? Both positive or both negative. So they'd be quadrant 1 and quadrant 3. So you're looking for one that in quadrant 1 and 3 is positive. Positive, positive, quadrant 1, quadrant 3. Negative would end up being quadrant 2 and quadrant 4. Quadrant 2, quadrant 4. So you could just look for positive and negative slopes, kind of roughly. But let's see. Indicate which differential equation is represented in the slope field. Briefly explain why. So here's a slope field, and we're trying to match it to a differential equation. So some things that you might look at here is you might be like, well, it looks like all the slopes are positive, right? So any of these that could ever give you negative values is out. That's always going to be positive. That's always going to be positive. Inverse tangent looks like this, and it has negative values. Now, this looks kind of like an inverse tangent curve, which would be the reason they put that there is to trick you. We're not looking for the function that matches the curve. We're looking for the derivative. So that would narrow it down to D and E. And after that, I might say, well, it looks like the graph is kind of getting steep in the middle. So which of these, like if you were to put x equals 0 in, this is going to be 1 over 0. This is going to be undefined. So that might fit that one. This one's going to be 0, which is flat, which I'm thinking that doesn't quite make sense. So I might eliminate that and go with this. Right? So, I mean, that to me seems like the quick way. Otherwise, you could try and solve each of these and see if it matches the graph, which is probably not the best way to do it. Like you could separate the variables. Does that look like a quartic? No. Quartic would be more like this, right? You know, so this is x to the 1/3. So be y equals x to the 4/3, which would always be a positive graph. And this has negative y values, so that just makes sense. So, you know, different ways of doing that. I don't think you can integrate this. Can't integrate that. This one right here, the right one, if you were to solve it, it would be x to the 1/3 divided by the new exponent plus c. Cubic, this does kind of look like a cubic, right? So that kind of, again, reaffirms that. This would be x to the 5/3, which, I don't know. I mean, it might look kind of like that, but it's going to have a 0 slope in the middle. So just some ideas, things to look for. On the back, differential equation may also be a function of just y or a combination x and y. For example, the slope field is created by the differential equation dy dx equals x over y. Describe any patterns you notice for regions of positive, negative, 0 slope as may be determined by x and y values. So, you know, like if you're looking for dy dx, you know, when is it going to be positive? It's going to be when x and y are the same sign, which is going to be quadrant 1 and quadrant 3, which totally makes sense, right? And you can say, okay, when's dy dx going to be negative? Well, that'd be when x and y have opposite signs. There's going to be quadrant 2 and quadrant 4. Negative slopes, negative slopes. When's it equal to 0? Well, that's going to be when x equals 0, which is the y-axis. So along the y-axis, sure enough, 0 slopes. When's it going to be undefined? Vertical tangents. That'd be when y equals 0, division by 0, which is the x-axis, which looks like that. So just things to look for. All right, now this is a problem either exactly like the one we did in the homework. It's either the same as like number 3 on yesterday's assignment, or really close, but we can't separate the variables. Okay, that doesn't mean that there isn't a solution. It just means that the methods we have, we can't find it. So the general solution, or they call it the non-exact solution, there's actually there is a solution for it, for this one. It is y equals c e to the x minus 1. That's just what it is. So if I gave you an initial condition, and if you use that general solution, we could find the c value, right? We could say, okay, well, this is x, this is y, so plug 0 for y. We could solve for c. C equals 3 over e squared, and then we could write the exact solution. So you'd say find the exact solution. They might call it particular solution. They might call it specific solution. There's all different words for this. So then we can rewrite it. We can say, all right, y equals, the c value is 3 over e squared. And we could simplify it, rules of exponents. So it's kind of like a weird kind of exponential. So depends on initial value though. You'll get, very different graphs. Okay. The slope field, draw the solution curve that satisfies the initial condition. So this one's kind of hard to see. I don't know, -1, 2 might be like right there. So following it, it's either like this, and there might be like a vertical asymptote there. I mean, it sort of depends. It looks like it's getting steeper and steeper as you get close to it, or it kind of goes like this. But I kind of leaning towards the first one. Okay, next one, -1, 2. This is kind of looks like one of those graphs, like right above this, the slope fields that we get. So it looks kind of like that. But if you ended up down here, it would look like that. If you ended on the line, it'd just be a straight line. All right, try the assignment today worksheet and get some more practice with slope fields. Just getting good at working with them.